Cool.
So if we start out here, our basic old style tools would be high-speed steel. When they come like this.
Okay.
They're just angled on two sides. You'll see in some things, especially old Sears catalogs, there will be where you can buy left-hand turning, right-hand turning, finishing tools, all this. And I got excited about those when I was a young man because, wow, these are cool. You can buy all this stuff and you don't have to grind them. That's not the way it comes in the real world today. And they were just way overpriced. Almost nobody bought them even when they were available. You can buy old tools that people have made, which we have drawers and drawers back there of ones that we have made. A lot of times it's better to take something that somebody's already ground on because you have less grinding to make it. But I wanted to show the way the stock comes when it is new. When you're using high-speed steel, you can get it in different sizes. We try to stock several sizes. This 3/16 is the smallest. It's made in China. It was local.
Wow.
It says China.
Oh.
I call it China lots of times since there used to be the town of China right next door to where we live.
Right.
So I say it's because nothing is local to Alaska hardly. If it's not made in Alaska, it's imported.
Yeah.
It's imported. If it comes from the lower 48, it's still imported. We're not making it here. It's imported. Anyway, yeah, 3/16 is the smallest one I've got. And just for reference, this Chinese high-speed steel, last I bought some was like $4 for a piece. It was not expensive. Regular, I think this is a name brand. I forget who it is. It was high cobalt. The marking's all worn off of it. If you go to buy this, it's like $200.
Ow.
So they can get expensive. They can be fairly cheap. Somebody Supreme. Yeah, I don't know. I bought it probably. Most of the time I buy these off eBay, or this was, even though it was expensive, if you had bought it new, I bought it Boeing surplus for $10.
Okay.
Because that's the way we do a lot of things. We try and save some money. This one here, just for reference, I kept this one out. This was my initial test piece that I had chucked up to show the strength of what you can do with CBN. This is a good high cobalt, high-speed steel, and we turned this down with the cobalt bit. That was my first test of what you could do with it. So that was
Wow.
the CBN, cubic boron nitride, is pretty impressive.
Yeah, it made nice work on that.
But it's also it takes a while. It's not super quick. When we go into and we can see also again with our clearances, like we were talking about. That was why I brought these out. Inside of your boring, you've got a clearance below it. You could tip this up a ways even yet and have it cut. You can come above center and it will cut, but you notice how the rake angle goes away if you're flat and you
Yeah.
raise above center. But if you go way down below center, now this one has a lot of clearance. It's an excessive clearance angle, but if you do go way down below center, you get to a point where you can't cut. You're actually out of the cut. But above center, you can go all the way up, and it's not going to cut well up there, but it's not dragging. It's still on the cutting edge.
Yeah.
And then we can look at the outside similar, where it's just the opposite. Up here, you get out of the cutting edge really quick on an external if you're too high. And on the other hand, if you were low, you could even have a tool that was excessively raked back if you start going lower.
Okay.
We have got carbide brazed on, this is where they started with the carbides. And the K21 Kennametal, the actual K21 Kennametal, is an extremely good brazed on for brazed on tooling, which is antiquated. I have not been able to find many of these. These are rare. There's a lot of them that will reference the K21, which they basically are meaning just a C6 carbide, but the specific K21. Now you can buy K21 inserts that you could braze into a piece of steel. And those are because that's a low-end insert, since inserts have developed so much further than when brazed on tooling were common. But to get an actual K21 Kennametal with the, you know, brand name, the whole thing, is pretty rare. And that's about the best of the brazed on tools that I have found. One that comes close is a company called Micro 100. And they make some pretty good inserts, but they're not as fracture resistant. They wear a little longer, and they have one grade for everything. They make a good grade of carbide, but they're not as fracture resistant in intermittent cuts as the K21, from my experience. They claim they are, but I haven't seen it in actual real life. This one here is an Isokar, an Israel company. And the numbering on this is the IC50 is their Isokar Carbide 50. That would most likely be a C5 grade, but I'm just guessing. That would be their rating. The important thing here is the C10, and the C is the shape of the carbide. The C is just a straight gouging square, which you can then regrind to make something else out of. But it's generally, when you're using tools like this, you take your new ones and you do your minimum grinding on these. Don't try and save yourself the extra use your used ones for what you can. I don't think I brought much. Here's one used carbide over here. And I don't remember. That was, I know where this came from. This actually came from another shop. We bought a bunch of tools from another shop this summer that was no longer in business. This one was for cutting snap ring grooves with a lead-in taper inside, and it's a very nice tool. So when you go, and it's already ground. So this is worth more to me than the piece of carbide.
Yeah.
Somebody's already spent time on it. And you go in here, you notice it'll make a little bit of a flat where the snap ring groove goes in, and it has a taper to this side so that you can start putting it in and it'll just go in all the way. Now that doesn't make it as strong of a taper. It's more likely to move on this side, but sometimes you want that depending on what you're putting together. One of the things you could have on this, let's say that this was in a blind bore, and you had your snap ring in a groove that was deeper than what the snap ring takes, so you can totally compress it like with a ring compressor. Put something in here, and then it will push down here until it comes to this and nicely ride in. And the other thing it will do is, see, it will ride in and it will stop it from moving in this direction. But if you want to take it apart again, you can press it this way. It will compress the ring and come back out.
Yeah.
Not a tool you're going to use every day. Obviously, reverse circlip, there was some reason that he was working on it. They labeled what it was for. Wasn't made here, but yeah, it's a good thing to have. The E's, which is what this is an E10. And the 10, I forgot to mention before, the number is the number of eighths of an inch of the square size on these. So there's this numbering system to it. There's a numbering system to all of this stuff. I won't go through all of the numbering, but the basic that it exists, that the numbering system exists, is probably of more value than anything. But the E is a common one you'll find. That's E is for 60-degree included angle. This is for normal US threading.
Okay.
So this is one, it's pretty common to want to have, is the E's. Part of the reason why you'd want brazed on tooling rather than, say, an insert tooling, which we will get into in a little bit, is you may want to reach out a little further somewhere, a certain angle, a little more options. You might want to take this tool and weld it onto another bar.
Oh,
so you can actually weld this down to another bar and stick out somewhere. I don't use them that much, but there's times when I use them that it is the answer. It's another tool in the box, and since that was where we started, that's, you know, earlier vintage than the clamp-on tools, that's where we should also start with some of the description. This one here is one of the favorite, is the A. The A means it's just standard cutting.
Okay.
to a square shoulder. There's a little, it'll be like a 1 or 2 degree relief here and a 3 degree, I think it is here, for relief. So you can cut up to a square shoulder and come back. The R means that it's right-handed. And right hand means that you're working on the right hand of a part. So if you have a part here, you would be facing on the right hand side.
Yeah.
This tool wouldn't work on the left hand side. If you're turning from the right hand side, and as you're going to the left, you're still making a ridge that's on the right hand of the part. It will cut all the way across, but you start on the right hand side. Your cutting is on the right hand. So that's the AR. And that one is an 8, so it's a 1/2 inch as its section. It's 8/8. Excuse me.
16th.
16th.
Okay, I was wondering about
yes,
that.
Yes, I get those sometimes. See, again, it's better to remember the concept than what I tell you.
Right.
Concept is much more important than I'm good at concepts, yes.
So this is actually
It is a 5/8,
yeah.
and that is 10/16. And yes, I should have realized that. But, oh well.
Yeah, you got it.
Yeah. And this one is a Yugoslavia. This was probably, again, a C, it's a C6, C5, and since I know that that's not 5/16, it must be a C6 for the size and C5 for the grade.
Okay.
It could be the other way around if it was 5/16, because C6 is also a grade. But as it is, the C5 must be the grade and the C6 is the size, because that's the 3/8. This one started out as an AL, and an AL 1/2 inch, and there's not much of it left. Actually, I guess it goes on this side up. It's been broken enough after being sharpened. There's not much left. It's almost, but I won't throw them away until they're used up,
Okay. Yeah.
because there's still some value in this. Also, as you notice, this carbide here will still hang on, but it doesn't have a lot of area to braze to. You know, what's left where it's brazed, you've got very little area left and a little bit of a shoulder there. When you have a new piece, you have this whole curve. It's milled down slightly so it sets in. Besides the silver brazing, which holds it real good, you have the fact of a pocket behind it. And the pocket behind it for normal cutting will never make a difference. I make a lot of brazed on tooling, just like this one that we made for the slaughter. This is high-speed steel and high-speed steel. And this one we just silver brazed directly on the top 2 pieces. This is for making a keyway.
Yeah.
That goes with our slaughter videos too. But anyway, the silver braze, without having a channel to put it in like these have, is actually still, even this one's high-speed steel, but even on carbide, I've never had any problem with the carbide moving from that. What I have seen, and this is pretty much not done anymore because you don't do the level of production with brazed on tooling that we used to do. In old days, I have used these hard enough so that I would actually see the silver brazing in the insert as it was glowing start melting away.
Oh.
So I would be turning on something just super aggressive, no coolant, because the coolant in this situation was just more of a mess than what it was worth.
Yeah.
Even though we're getting more wear on the tool, it would have been on something that was welded up, big radius on the front of the tool so that it didn't chip it away, and just crudely coming in, probably a tool that was already half used up lengthwise too, so we're not heating so much carbide. But I've actually seen it where it was hot enough that the silver brazing was melting, and the only thing that was holding it was this shoulder that it was working against. And when you see that, you stop for a second, back off, and resharpen your tool, and you can save the tool. That's the only time I've really seen the shoulder have an advantage, is when you're extremely overworking the tool.
Right.
The other advantage is, though, if you're a manufacturer of these, the people placing this in, it's always in the same place. You know where the carbide's going. You could make this with a bigger piece of carbide, just lay it flat on a surface that was lower, and then come back and grind, but you'd have to grind a lot of the carbide off to come to the same location. where when they make this piece of carbide just slightly larger than what it needs to be. They can braze it in, the pocket positions it, and they can quickly dress two sides and they're done.
Okay.
So from a manufacturing standpoint, it makes more sense to have the pocket than really needing it for the tool. But it looks like it's really something that you have value there. The B's, I don't hardly use the B's, but the B has, it was a common thing at one time too. This will be a BL, and it's right there. It's a BL12. Again, it's a K21. So this is 3/4, 12/16 of an inch. Not 12/8, 12/16 of an inch. And the advantage to it is just more clearance coming forward. Okay. You can set this forward straight, you have more clearance, but you can't come to a square shoulder. So this is a better tool if you're just roughing off lots of material than the A is. The problem is that we're not normally using this. Usually to rough off lots of material, we use a holder with a throwaway insert. The two advantages to that is, one, you're just buying the insert, possibly even turning it to a new corner. Like this one has 3 corners that'll rotate around. The other thing though that's even more important than being able to use this 3 times over, say, this A tool here, the real advantage is I've set this up, I know where to stop next to a shoulder, I know what diameter I'm going for. When the tool gets dull, I can rotate it. There will be a slight difference in my locations of my tool, but it's close to the same. So I don't have to reset what number I was stopping at on a dial, where I was going on a digital readout, especially for CNC. Very, very helpful. Although sometimes to get into a place due to the way a CNC machine is made, you'll go back to braze-on tooling, because all the different parts of the tool, the machine moving around, you got to have this sub spindle close to you, something else near, and you want to get in to make a little cut without stopping. Well, you go back to a brazed-on tooling sometimes, even with a CNC. But you have more problems with setting it up. It's harder to set it up. It's harder to deal with. Where when you can go to an insert, anytime you can do that for production, one-off, it doesn't matter so much. It's more a matter of just, this is a one-time tool and this one's renewable. This one's another B, and again it's an L, and it's an 8, so that's 1/2 inch, or 8/16. This one is the other one, similar to the E, is the D, and the D is 90-degree included angle instead of 60. Same idea, and this is just a protective dip coating. It's on the tools a lot of times when they're new, but not always. And some of the shops I've been at, we used to, you take a slow cooker, set it up, I think around 200 degrees, I forget, but anyway, and all this stuff, you can melt it back down. You can buy this for protective coating, and you just dip it. Oh. And that way it can bounce around in the box a little bit without hitting the sharp edges. It protects some from corrosion, but not that much. I've seen many times where the water, if you're not careful, it will go down in there and actually hold next to the tool instead of staying away. Right. If, however, you have this and you keep them in an oiled environment, it will help a little bit more for holding the oil in and keeping the corrosion down. Yeah. It's not a guarantee against corrosion, though, as it's somewhat, you see it more on the solid steel tools that it's dipped on, where there's a problem more so than with the carbide. This one is an interesting one. We'll go ahead and unwrap this one. This one is also brazed-on tool. These are not used much these days. A couple of reasons. One, a lot of the sellers just don't have them. They're hit and miss on finding these. And two is it's just quite a bit different than what most people work with and think of. But this is actually a wonderful tool, especially if you had it in some smaller sizes. And this is a TSA 8, so it's a 1/2 inch, and I always forget what the letters on this stand for. Yeah, it's a TSA is what it is, same as the other ones. But what this is meant for is for boring holes. Oh. Specifically for boring holes. And here is is, as you can see, if we're boring, we could come down here at what would be center line, and it's no different than any other tool. The advantage to this is the geometry that it has when you are lined up right in the middle of the hole with the thickness of the insert. And the reason for that is in line boring. You're out in the field, you're reboring something, you will have, I should have had a bigger piece of shaft here, but this is the general idea. Imagine for a second that this is the one. So you have a square hole that's cut in this tool, in this driver bar, and this will be turning around to cut holes. So since you can't cut it offside, if you cut it way off to one side, now your bar is in two, essentially here. It's going to bend, it's going to flex. You have to cut your hole in the middle of your bar.
Yeah.
So when you cut your hole in your middle of your bar, to get your ideal geometry, you go to one of these tools. The reason why they're not that common is because most people with their line boring will, instead of using the correct tool, because it's hard to get, I don't blame them. I've almost never used these with line boring. It was just when these became available, I bought some. You know, anytime I see them that are at a reasonable price, I buy them. And I don't even like doing line boring. I don't do much of it, but I've done a lot of it. And this one here, you can see if we were putting this on the thickness, on center, we've got the wrong geometry.
Yeah.
We're above center, but it will still cut because we're above center. We're cutting inside of a hole. It will still work, and this is a common, easy to get tool. So normally you go ahead and just use this. The biggest problem with this is, since our cutting edge is above center, as we move out, it's harder to be consistent with the size. We're not cutting at the diameter of the part. We're cutting a little bit big, so when we move, it's going to want to take more metal than what our direct movement is. Of course, our final cut, we're taking such a small amount that inaccuracy is not normally going to be a problem. But it exists.
Okay.
And again, and this one, the TS, it doesn't bring you, even at that, you're still, even with this, we're still cutting above center. We're just having a better geometry. So actually that measuring problem is still going to be a problem because you're still moving here and cutting at a point up above. You just have a nicer rake. It cuts smoother.
Okay.
It's one of those tools, not very often, but it's used there. Then we go to insert tools. Insert tools are somewhat similar, and I have not totally figured out all of the numbers on these. There's different regiments for the numbers for the holder for different companies, but also some similarity. This one is kind of by the standard pattern. I noticed that Char's, that's a importing company. They have the stuff made in China. They tend to have a little better quality overall than some of the other Chinese stuff. They're not U.S. made. There's still some problems now and then. They're not necessarily the best of tools, but they're a reasonable, affordable tool.
Okay.
M is multi-clamping. C is, I think that's just straight clamping, which is what we're doing here, even though the insert has a hole for a lock pin. There's no lock pin on this.
Yeah.
I think the C was just multi-clamping. Anyway, your first letter is how your insert attaches. The second one is the shape of the insert that you're using, which in this one is triangular. In this one, it is what they call a V shape, which is a very V-shaped trapezoid, I think I'm right?
Yeah.
Yeah, trapezoid. It's not a square.
Or, well, is it a trapezoid or an isosceles triangle?
It's not a triangle. No, it's four-sided.
Oh, yeah, look at that. That's a trapezoid.
Yep, trapezoid. So, yeah, and this is multi-clamp. This one, it has multi being the pin in the center. And you can remove the pin. You can get a different screw for that if you don't want to use the pin, if you have an insert that doesn't have a hole in it. Sometimes you don't want a pin in there at all.
Okay.
Or you could use just the pin. For some people don't like using the clamp on the top. I like it. I want to hold the insert as good as I can. I've talked with several machinists that tell me that once you put the insert in here, the cutting forces should hold it down. But I've had so much get pounded away different times. I just use things to extreme. And their argument is if there's a little bit of inaccuracy in the base, that by clamping it, you're causing a rocking here. So you're pushing it back here, and then when you go to load it, it can make it move a little bit from the force of coming down. There are some tools that clamp in the same as the cutting force here, but I don't figure that the base is inaccurate enough to be a real problem.
Right.
I just want to hold it as best as I can. But I do understand their point of clamping at the back can raise the front a little bit if there's some micro imperfection in the surface there, and now we've got some movement on the tip, as opposed to just clamping it with this and letting its own force drive it down and hold in a consistent place there. I go with clamping. I like clamping. In fact, I would much rather use clamping than any of the pins, and I usually use both just because it's there more so than finding it. And this part underneath the insert is called a shim. And the shim is what the insert directly sets on. That is so that you can replace it when you have a crash. Something comes in here, breaks the insert, tears things up, and you can just replace the shim underneath.
Okay.
Usually when it does break it up, it will tear up part of the underneath support here, and you'll clean it up and have a little bit less holding it there, but it still works. The carbide bridges it out. This tool is mostly for profiling, making fancy shapes on the outside of things, like when I built my cannons. That was my first production item out of the shop, actually, was some 58 caliber black powder cannons. Not that it was a high-tech thing, but it did a lot as far as building the shop up, and many times I've had people look at the pictures of the cannons, all pretty polished, and they say, wow, if you can build that, you can really do precision stuff. Cannons only got to be accurate, the bore within 10,000ths of an inch, and overall outside within 1/8 of an inch. I mean, it was just crude, but you polish it up, people look at it, and they think you are just the most wonderful person in the world. So that's good for shapes, if you need to do fancy shapes, because you've got lots of clearance built into it. It's not good for heavy cuts. It's not good for a lot of just general cutting. Why spend the money? The tip, since you've got less support behind it, will wear away quicker. Even if we're doing light cuts, it will wear away quicker than one that's got more support holding it.
Okay.
But it's great for what it's for. Getting on with let's look for a second at our other insert tools that we happen to have here. Now this one here also, as we notice, is left-handed, and this one is meant for facing on the left hand.
Okay.
That's really what it's meant for. You really can't turn with this one at all. It's just really specifically meant for facing. This is also meant for facing here. This one is a D, which I think the D in this case means dual. C on this one is for clamp, which this one is strictly a clamp. I don't think I've ever used this. Well, no, I have. It's got screws there. I must have had inserts in it, using it at one time. This probably was on machining, doing some portable machining on a 994, was rear axle mount. We did that out in the field, and I think that's actually where we used this. Anyway, so it has the C for starters, so it's just strictly clamping. The T, again, it's triangular. We hadn't gotten that far along. The F, P, I don't know. The F, I don't know. That would be for facing in this case.
Oh, yeah.
Yeah, it would be for facing. The P is for positive. This is for holding positive inserts. We talked about that before, whether they were positive or negative.
Yeah.
This one here is for negative. And on this one, they actually say what the insert series is. It's a TN-33. And by 33, they mean it is a inscribed circle of 3/8 of an inch or a insert that would start with the 3 and then the second number, which would be a 3, which is 3/16 of an inch thick. And then the last number, as we normally would use 3 numbers for our insert, is not there. And the reason it's not there is because they don't care on the holder whether we use a sharp corner for our radius or what it is. So the last number describing the insert radius doesn't matter to the holder.
Okay.
So that's in the insert. So you would use, and you would have the actual insert you would use would then, as you expand that number out, and this is nice when they put all the information on the side. What's really nice is, I've seen it on the newer Dorians, it's not here, where they tell you all of the pieces. They tell you the chip, what do you call it now again? The shim. They tell you the part number for the shim, the part number for the screw, part number for the clamp. On the newer, some of the newer stuff, they tell you everything on the side of the tool. I love that. They should all have done that from day one. But they didn't, and that's part of where, especially when you're buying used tools, it becomes quite confusing as to what it is. Many of the sellers on eBay, too, when you're buying used tools, or even new ones, if they're surplus, of a holder, the guys selling it, they just go and they buy a whole bunch of stuff from somebody and they're putting it for sale. They know it's a lathe tool, but they don't know. You ask them, what insert does it take? It takes the carbide insert. Okay, thank you very much. And you try and do your research. Sometimes you can figure it out. Sometimes you can't. Sometimes the numbers will be some old, slightly different numbering system or specialized for a little different clearance or, a little different angle than a standard one, so it's made only for Boeing for this application or for General Motors. It's not normal numbered. The guy that has it doesn't know what the insert is. Once in a while I buy a whole box, where you might have a box of 20. I haven't done that for years, but where there's a box of 20 insert holders in there and the whole box is $30. Okay, you take a gamble. I found out though that generally those were bad gambles. I found very few of them that I could actually use one way or another. They had already tried selling them individually and they got put in the box because nobody wanted to buy them.
Right. Yeah.
So these were the weird ones. Even though they looked standard, they were weird. So the insert that this would be most common would be a T and G would be the most common you would use in this. And the G just stands for ground. It's a triangular negative insert. Ground is precision. So, and then it would be like a 332 would be the most common, which would be a 2/64 radius on the cutting edge.
Okay.
And this one here is a 1/64. This is a little bit sharper than your 2s. You also, 333 is real common. Another one that you'll see is a T and U, and U is utility. And that means it either was ground inaccurately or not ground at all. So when they make these inserts, they can make them without grinding them, where it's just formed and it's good enough. Okay. And U is a utility. So if you're doing rough cutting, it doesn't matter. Sometimes you find a bunch of old U inserts, and I say old because almost nobody makes a U insert anymore. It doesn't save them enough money to run through and make a special line of low quality inserts that are not as accurate as the others. But the U's will vary more in where your cutting edge ends up when you rotate it. Okay. So instead of changing your size by 2/1000ths of an inch when you rotate it and it's a little dull, it might change by 5/1000ths of an inch. But if you're ripping off material that's only got to be within a 1/16 of an inch, it doesn't matter. Right. It's a cheap insert, use it up. Or it was supposed to be a cheap insert. Also on here, if we look further in our numbering, this is negative, it's left-handed, 1, 2, 3B. I don't know what all these are about, but I know that the letter, 1, 2, okay, this is a 12, so that is the 3/4. And the third, this is the point I wanted to I do know actually, yeah, the 12 and the 3, I'm not sure why the B, but I've seen a B on a lot of them, and I've come to the conclusion that the 3 is the 3 for the insert, the number 3 inscribed circle.
Oh, yeah, okay.
So this, because this is the designation, this is the insert it fits, and it's actually, it says INS, insert TN33. So that part is just specifically describing the insert. This is the call-out number for this holder, without the additional information. So after we'd looked at this, it is D for dual clamping, T for triangular, F for facing, N for a negative rake, left-handed. It is 12/16 in size, and then it's a 3 for the inscribed circle of the insert. B probably describes, in a way, the thickness that the insert is, my guess, but I don't know for sure. Now, if you had this number on a Kennametal, you could quickly, if you saw the same thing but it had a 4B, you would know that it's using a triangular negative insert with a 4 inscribed circle, so it would start with 4.
Okay.
The B would mean something different for the thickness because it would be in relation to a larger insert. So it wouldn't mean that necessarily that you're at a 3/16 per se for the B.
Right.
Or I think that's the way it is. I know the rest of these. You can use some of the numbers on a cutter you've got to vary and see the difference for another one. Or you can go look up in charts. But again, I found that the charts do not 100% relate these numbers and letters unless you also are from a specific brand. Inserts do match. A insert of a given designation matches. However, there's also additional letters they add on for variances that will be brand specific. But your most basic, a TNG, TPG, those are the same, whoever made it. Triangular, negative, ground, triangular, positive, ground. You start getting into like a TNMG, which is a negative with a chip breaker and a hole in it. Those should all be the same too. But while they're all the same, the chip breaker will vary from brand to brand.
Right.
So the chip breaker might work real good for you on one particular TN, and this is a P actually. This is not a TNMG here. I was just pointing to the chip breaker because it's on this one. But you could have that specifically. You love the way it's working. Everything's just perfect on this brand. You change to another brand, and you'll never get the chip to break. It won't work, or it will go to chattering terrible because, like you can see on this one here, where they're just not always the same. This chip breaker starts back a little ways. That chip breaker is not clear out to the front. So at the very front of this, you have just a clear cutting. Sometimes that chip breaker will stop vibration on a part because it gives you an extra positive rake where it's first starting in and letting it cut easier with less pressure.
Okay.
Where this end part here could be on a certain job just enough extra pressure to mess with you, where it's still a positive rake, but it doesn't have the additional double positive from having the chip breaker all the way to the edge. Another chip breaker may be ground or formed closer to the edge and not be a problem. Then also, of course, your end radius will make a difference as to how it reacts. A larger radius will, if everything is secure, no movement, a larger radius will make a prettier finish. It will last longer. It also means you're not dead square up into the shoulder where you're cutting a shoulder on something. You're going to have whatever the radius is away from there. So in certain situations, you want a large radius. It's clearance for a bearing. You want the strength that a radius on a shaft gives. In other cases, you want a small radius. You may also need for vibration because the larger radius is going to try and vibrate more because it needs that stability and you don't have it. If you're in the middle of a long shaft, this is 10 feet long. It's 10 foot, believe me, it's 10 feet long. And we're turning here, it's very critical, even if we're up near the tailstock, it doesn't take a lot of pressure for this 10 feet long to start vibrating.
Yeah.
Now we can throw a steady rest on here, we can do a lot of things to help that also, but this might be made out of non-obtainium and we don't dare scratch it with a steady rest. There's other things that could just where it has to be out here. There's another piece welds onto it, bend, some reason why essentially you have this light shaft and it's stuck way out here. Could be a special impeller with a whole series of light sheet metal pieces placed along it, and you've got to do some work on the end. You have to get your minimum cutting force or you're not going to make it.
Yeah.
So now in this case, if we have something that's an example of that, you have minimum cutting force, so you go to your smallest radius, you're cutting along here, but the shoulder still wants, because after this it's got something that needs a lot of strength, so it wants a big shoulder, big radius in the shoulder. So now we have to actually form the movement to make the shoulder.
Okay.
Which is common to be done on lathes. It's done on manual lathes as well as on CNCs. A CNC or a tracer will make a nicer radius. What you commonly do if you are doing it on a manual lathe is you get very good at running this at the right speed, just eyeballing it to where you don't make a perfect radius, but you make one that's adequate. Then you can come back in and you might dress it with a tool that has the full radius, but not come in to make a full cut, just to dress some of your high spots. Just touch a little bit and be careful not to let it chatter.
Right.
Or you will come back and look at it against a radius gauge and see where you have to dress a little more out. And then your final dressing of this, and we'll get into that someday, we'll actually do some of this. To actually dress it out, you'll take a die grinder or something, you come in here and you'll hit it with a grinder a little bit while the lathe is spinning.
Okay.
So that you can make a nice radius out of it and nobody knows that you used a fancy trick instead of a CNC machine. If they measure it against an optical comparator, yes, they will find out it's not a perfect radius. It's still good enough to relieve the stress in the corner and do the function that it's meant for.
Right.
These ones here were just some more tools for the slaughter, which really this is meant to be lathe tooling anyway, but since I had them in the box, it's again clearance. This has clearance on the edges. What this is for cutting forward. It pushes in, pulls back and pushes in. So you can see there's a little bit of a clearance coming down, lots of clearance, lots of rake actually. That would be the rake as it's cutting in and shaving the pieces. The chips would be sliding against this angle.
Yeah.
And making cuts for a keyway. We've gone away from doing this style because while this works, and this is a very good tool, it's a lot of work to make it, and we're having really good results with just brazing a piece onto our round stock. We have a lot of this 5/8 pre-hardened high-speed steel, and doing a two-piece we're finding is actually resulting in a stronger cutting tool, even though it looks kind of wonky. Let's go back to the inserts again for a little bit. I dropped some. Inserts. We have quite a few inserts that we use. Several of them that we just kind of toss around. The more common ones we use end up on the top of our organizer because we haven't put them back yet. We have boxes of ones that have not been organized yet. I have bought a lot of grab bags of inserts off of eBay. I don't anymore because no one is offering them anymore. When I first started buying these, I would get a box this size, well packed, not just thrown in there, but well packed for $100 delivered to me.
Wow.
And about the best you get today is $1 per insert is a screaming deal. I got lots. I bought probably 30 boxes like that when I first started collecting inserts. And then I narrowed down, okay, I've got lots of these that I don't use. And the idea in buying the miscellaneous, you gather them up, and then you get the holders to match what you have an excess of that you can use on a job. It's just a general economy thing. But anymore, I mostly buy inserts that I want because I have quite a few. I'm going through here looking at stuff. This is square negative ground 644. So, and the T is going to be specific to Kennametal, whatever that means. So we know when we turn this around, we're going to find square. They're going to be square on the side because it's negative. It's ground. It is 6. So this is, the inscribed circle is 6. For whatever reason, I got to stop. That's a half. That is 3/4. That's what I thought. Yeah, 3/4. And it is 4/16 thick. So that would be 1/4 of an inch thick, and it has a 4/64 radius on it. And yeah, and now as we turn it around and look at these, we can see that they're ceramic. Sometimes you don't know in other ones. I don't know why it's not letting me in, but we'll get in anyway. These are white ceramic, and the white ceramic, they used to say, I forget what they said about it anyway. This one here is ceramic. This was some that I bought in a grab bag, I'm sure, on this one. And as we said, it's 3/4 of an inch inscribed circle. Being square, that also tells you that it's 3/4 inch by 3/4 inch square, because you're just touching the sizes. That is what it is. The corners are 4/64 of an inch. It's going to be 1/4 inch thick. And ceramic tends to be brittle. Ceramic is wonderful. It likes pretty low forward speed in your cutting, but it really likes lots of speed, actual surface feet of material coming past. And so, and it does not like coolant at all. If you put coolant on it, it will explode because it's making, you're running it fast, you're getting enough heat across here. The thermal change and throwing your coolant on it will cause it to just break up. It'll just blow apart. So you use this dry. It doesn't normally like intermittent cuts, but some of the grades of ceramic do to a certain extent. And as I say, since this is a grab bag, this isn't one that I've used and really can say how well it works. Some of these ceramic inserts are just like, oh, okay, it cuts a little bit. I'm not impressed. You've got to just baby them too much for some of them. Others I've grabbed out and they all look alike, but I've grabbed others out and I cut for days and days on one corner and it just works. And there's black ceramic inserts there. These are square. I tried to keep these drawers according to square negative, square positive. We try to go on a theme, but we haven't labeled them. And some of the guys that have worked with organizing these haven't always put them back in the right place either. These here are gold coated. They used to always be titanium nitride was the gold coated, and they only used one coating. Now they use lots of gold coating, so people just say gold coated because there's different ones for it. This is a KC850. The KC850 series is one I'm familiar with. It actually has other types of carbide in between. It's not just one carbide. They varied the carbide in there to try and get a little bit more impact strength on the corner, along with the titanium nitride coating, which is a little harder than carbide. Yeah. These are great. The KC850 are great. In most things I'm finding in the surplus world, new, these are probably 30 bucks a piece. On the surplus world, I'm finding that about $3 a piece is the cheapest you're going to find any of the KC850 these days. They just don't come cheap. I probably bought these for 20 cents each when I bought them. But that was back old world eBay. That doesn't happen anymore. These are Cermets. This is a combination of ceramic particles bound with carbide and nickel, extreme amounts of nickel to glue them all together. These ones here, I don't know where I bought this, but the first of the TC30s that I bought at Boeing for $1 a piece, and I just bought them not knowing what the TC30 was, but just it was pretty. So I said, it's pretty, it's large, they were $1 a piece. That was before eBay was really place to buy inserts. Okay. And Boeing's standard was $1 an insert for their surplus inserts. Regardless of what it was $1. It could have been a broken two insert, it was $1. It could have been like these Cermets that at that time I think were about $30, $40 a piece, and they've gone up from there. These ones I bought off of eBay. I remember the ones with the little clipped corner, which is actually meant for milling, is what that's for. It's a wiper to make a second wiping surface a little different coming around on a milling cutter. It doesn't make sense just looking at it, but anyway. I the first time I used the TC30, I used them for cutting the teeth off, hardened teeth off of a bowl gear on a bulldozer where I was making some changes, and they held up amazingly well. I couldn't just use a insert and turn all the teeth off, but I could get it done in a couple of inserts where before with the carbide it was breaking up right away.
Yeah.
Just try and go through and glean some information we can out of these. This one here is the C shape. No, that's a C clearance, excuse me. It's still square. Okay. And this is a square positive. And that's something too. Besides P, there's other positive clearances. P is the most common generic, but C is another clearance, and you'll see this as a really common clearance, and I think the C was less of an angle than the P, but I forget. They're different. They're different. I don't remember. Again, your holder that it goes into, though, this one would go into a holder that would have its clamping method, and then it would be SC for the next numbers. It wouldn't be a P. Now, you can cheat that a little bit. Sometimes if it's a straight clamping holder, you can put one in that's wrong, and it will still work to a certain extent, but it's not going to set properly against the pocket. The insert will cut the same, but as it's setting against the pocket, it won't be setting securely on a surface. It will be setting on just an edge of the insert, and it may be damaging the holder a little bit or chipping the backside that you're not using of the insert. You still, though, on some of this where you'd bought a whole bunch of them for 10 cents a piece and you couldn't quite find the right holder, you say, yeah, okay, it still works. And you can also even cheat that more. You can use a positive insert most of the times in a negative holder.
How does that work?
Because if we have, you can't use the negative in a positive. Let's pull one out. Pull something else out. Oh, that one is a positive. Either one will give us the example. Okay, this is a positive insert. Your negative holder is tipped like this, tipped down.
Yeah.
Okay, so this can go in that same holder and it will still cut. You have your round surface, it will still cut. It's just in a different geometry than what it's meant to be. You don't have the edge strength that was meant to be with the negative holder.
Okay.
The negative holder, now we have an opener for this one too. Okay. The negative in this one here is, again, a ceramic. This one happens to, this is, okay, we're in the positive drawer. These are all positive. Let's go back here. Okay, back to our negative again. So our negative would be tipped down in our holder so that we can make clearance to our circle. We're cutting a circle. Okay, my thumb is a circle. Just don't cut my thumb. Okay, so we've got clearance there because it's tipped down. The positive will go in the same and be tipped down. It just has more clearance on the bottom than you need. So that means it's a little bit weaker. You can't get by with taking really rough cuts like you would with the actual negative insert, but it will cut.
Yeah.
It's not going to quit. On the other hand, this holder for this one is going to be slightly tipped up. So with a slight tip up, if we come in and we replace that one with the positive, it don't going to work.
Yeah.
It's going to just rub in the middle of the insert instead of cutting. So you can swap them wrong one way, but not the other way.
Yep.
Ceramic. Well, you can't see it in the camera. Ceramic, and this one I believe was what they called a whisker ceramic. But ceramics are light. Carbide is heavy. Ceramics are light. CBN is kind of in between the two and can be tough to figure out sometimes. These were the C's that I thought I was getting into before. The C shape. It's just a slightly squished square.
Yeah.
When they first came out, And the main point you use them on is this one here. It just gives you a little bit more clearance in two directions for coming up to square shoulders. When these first came out, what they were saying was it's a dual purpose insert. It is for doing your turning here and your milling on this side. And so what you'd do is for rough milling on a surface. Well, most of the time in milling, while it's a beautiful insert on its edge here for milling, and it will just hold up beautifully using this insert for a different function. In most shops, it's not used because they normally want a milling cutter that will come up to a square shoulder in the smaller sizes where these are used. So while this is a positive, it's a 4 cutting edge insert. Normally, you're only using 2 in most shops. I have a complete drawer where we put worn out inserts, and if we use these and we've worn out these, they'll be over there in the worn out drawers to where we can still use the others later if we ever have a cutter or make a cutter for that. But the cutter that these were originally meant for, where you could do both real easy, it doesn't readily exist. They used to sell them in sets when these first became popular, and it got dropped because people weren't using them. It's got a purpose in facing. The real purpose where these would be absolutely wonderful in a lot of shops is if they made large face cutters. Because a large face cutter, a lot of times you got a 6, an 8, a 12-inch cutter. You're not coming up to a shoulder. Those are a lot of times just flat surfaces that you're blanking out. And this would be a beautiful one to use this edge without all the clearance. To just let it just cut. It would cut for a long time with that the lead-in angle, a lot like a square, which is a common one to find. They'll use a square one the same way, but on the square one now you have 4 corners you could use.
Right.
So this one we have to first wear it out on the lathe before we decide to use it to a mill. The scheduling and function of that, it just doesn't happen, and a lot of the bean counters don't understand that either. As they buy the inserts that people want, and a particular manufacturer recommends, oh, use our C inserts in this holder. And the guys out in the shop, of course, know what's going on. They're only using the 2 corners while it's advertised for 4. And yeah, but it gets used at a certain rate, so they buy them for them and they make stuff. And the guys that don't know are happy about it because you're still making stuff. You save the day in the shop, and the guys that don't get it don't have to know. Here's another one in the TC30 Cermet grade. And yeah, and this one here has a chip breaker, and you can see on this one, even though it's bigger, it's got a little less of a land at the front of that chip breaker than that small insert we were looking at earlier.
Yeah.
On the other hand of this, though, it's got some land all the way around on the chip breaker. So again, the chip breaker will be a given designation. This is a CNMG, so it's a C shape, and NMG for the chip breaker in a hole is what that means. But the chip breaker is different according to the brand. These are old ones. Oh, yes. And these were meant for one side. It is a negative, but it was meant for being used on one side only, where it has the chip breaker here. Very nice, excellent for doing tracer work or CNC work for shaping things. And but not for hogging stuff off.
Yeah.
And I don't know what we got going on here. Okay, more similar ones. And it's got a lot of positive to it in both the point, and the sides are still positive into the chip breakers. That's that V shape. Come down a little further, we're in our generic triangles. I almost hate to say this, but I will. The A66N Ceratip. This is a ceramic. This stuff is amazing. I hate to say that because the prices on these on the surplus market have been going awfully close to new, and they're just way too much money. But I lust for these. These are great. They just work. Not only will they cut hard material, intermittent cuts, They'll have reasonable accuracy, which you don't normally have with ceramic inserts. Normally, you have to go back to a carbide to get a more accurate, because the carbide has a sharper corner. Your absolute sharpness of your corner cannot be as sharp and hold together on a ceramic as it does with a carbide. Carbide will hold a sharper edge.
Okay, yeah.
And a I look stupid. Oh, that's the other side's got the tip's got to go away too. What a terrible trouble having all these new packages that haven't been opened. Okay, when we need to, we'll take pocket knife, Howie's pocket knife, and we'll break into that. I don't care. Doesn't matter right now. But I guess it does kind of matter with my point, though. And we got one back up here. We'll do the same thing. I don't think the camera will show it, how that has just a little bit of a round in the actual cutting. The absolute sharpness of it can't be as sharp and hold up as the carbide because it doesn't have the fracture resistance. If you could make this really sharp, just like you can take a piece of porcelain ware and you break it and you cut yourself super easy because it's really sharp, but it won't hold that extra sharp. You need to have a little bit of a edge there that's either a 45 degree is common or a radius on it. Most common is I'll just put a 45 degree. And you really can't hardly see it, I don't think, on the camera, but in real person you can see it. And that having that larger surface there that has to be between the part of starting a cut and being into the cut where the chips are rolling off, that makes it harder to be accurate for your final cut. And then we're down to our triangular positive. Now these ones here, actually, I guess I was wrong. This is actually fairly new made. This is an outfit that makes these inserts in China. They make different grades of them. Their price has slowly been going up. They're not really good inserts, but they're adequate. So if you can't find the insert you need, you can pretty much go to these guys and get one at a reasonable price instead of having to wait for the high-end insert on a surplus deal. But this one here is a TPU. It is the U I was talking about that I said was pretty well not used anymore. Apparently, these guys figured that making a U series, or it could be that they're actually G's and they just label the box U and charge you 50 cents a piece less for them because it's a U. That's something I've seen with a lot of manufacturers too. They'll make the same thing, but they'll sell you some of them for less. I don't know. When I bought them, I think they had them labeled only with the U's. This is our cubic boron nitride drawer, and there's a little bit of all kinds of shapes in here. Usually when I can get a good deal on it. These ones here I just managed to buy. I'm debating whether I want to buy more of them or not. They were $10 per insert, or $100 a box. The man has a few more of them. I bought 5 boxes. And we tested out one of the inserts. Austin used it out here. He was turning some high-speed steel that was already hardened, and he said it worked great. So we know that they are actual, real. These are solid with no coating. The list price for these on sale, the best price I could find listed for normal purchase, was $281 each. Wow. For each one of these. So $100 a box is a pretty good buy. On the other hand, this is not a shape. Round shape is a good one for a lot of stuff. These are used many times on head surfacers for automotive shops. But I don't really have a lot of use for this, so putting $500 into one size insert that I don't use much, I don't know if I really want to buy more or not. I'm glad I bought those, but I'm arguing with myself whether to buy any more.
Yeah.
This drawer here, these happen to fit some bar here, I think. But the main reason why these ended up here was because some of these are specific sizes that work with some of the inserts in the CBN drawer. So that's what that drawer's about.
Okay.
Well, they can be used for other things. They don't just fit that. It saves looking all over the shop for a couple of the strange sizes of CBN inserts for holders for boring drawers. And these ones, little parting inserts. There's a lot of different kinds of parting inserts, and they're always changing them. I don't have any holders, haven't been able to find a holder that fits that. It's there. These ones, I forget where they came from. But again, this is one of those special brazed on tools. And this is kind of unique when we look at it here too. This is brazed on together straight right there. It's all carbide on the front. And then we have a steel shank that brazes on just flat on the end. So someday we'll use them. I don't remember. They came with something else. It was like these were basically free. There was a box of inserts that I wanted, and these were in it. And so they came free, and yeah, you sort it out. They're good. These are very good little grooving tools. This is a groove lock, I think they called it, but I can't find a lot of the holders for these very easy anymore either. Real common at one time, and I don't know enough about it to actually, if we get to where we needed to use a lot of these, we would go back and find the holders. Looks like that's more the same, different widths. Yeah, different widths, different direction. Same direction. I'm looking, no, it's backwards. And that actually clamps in backwards too, yeah. The groove is on a different side, so it's a totally different holder that has the clamp made backwards too. There's definitely a left and a right. I don't know enough about those to be buying in holders for them yet. They're really a good system when you have all the stuff. I'm guessing that those were dirt cheap. I don't remember. I think that's, yep, spare drawer. So we're down to spare drawers. And that's a little more information about tooling.
Yeah.